Alright, so this lesson is called the Function Families Review. We started off the chapter talking about the different parent functions. So we're going to put it all together. We're going to talk about parent functions and the transformations and the end behaviors and all that stuff. We're going to put together the interval notation from back when we talked about interval notation in the past chapters. So we're kind of putting it all together as this final section of this functions chapter. All right, so what I'm going to do, my plan is to do just 1, 2, and 3 because they are the three different functions, linear, absolute value, and quadratic. So you get example of all three, and then you can do the classwork. All right, so I'm going to go through all three. All right, so the first thing I'm going to do, and again, if you get stuck on any of this graphing, use Desmos. That's why I have Desmos over here on the left here, in case I need to use Desmos, or I can review with Desmos as well. All right, so to do graphing a line, that one I'm just going to use y equals mx plus b when I solve that. So again, I'm putting my equation down. This is where I start on the y-axis. And again, this is my slope. Okay, so we know that this thing should be going negatively or downhill. So when I get done with this, my line should be facing in that kind of idea. All right, so first thing I'm going to do is go up to the 5. 1, 2, 3, 4, 5. Put a dot. And remember, it only takes 2 points to make a line. So I'm going to travel 3 and over 1. And again, if your graphing a line is still weak, you can always use Desmos to kind of help you out with that. You just basically go ahead and put it in Desmos and then read a couple of points so you can read off the graph, and then just transfer it onto your graph here. All right, so there's my line. So it says, what is the parent function? Our parent function is f of x equals x. Our domain, again, we talked about this before, talking about all the x's. Now all the x's are covered because, again, this line is going on and on and on forever, slightly off to the right each time, so x is always going to have a graph with a y. All right, and same thing if I go in the negative direction. Any negative x I pick, I'm going to hit a y somewhere on the graph. Remember, if it hits a graph, part of the graph, then it's in the domain. So this would be, again, all reals. You could say that little funny symbol, which means all reals in mathematics. All right, not to be confused with this R, this means range. Okay, so in the range on this, y is allowed to be whatever it wants as well. It has no limits. So both of them are reals, all reals. The number of roots means how many times can it possibly hit the x-axis. The answer to that is 1. All right, end behavior means what is going on with these arrow points. Okay, so as x is getting larger, as x is going this way, y is going that way. So that's going to be negative infinity. Okay, so as x is getting larger and larger and larger and larger, y is getting smaller and smaller and smaller and smaller and smaller. Okay, in terms of negatives. As x is going in the negative direction, okay, so x is going negative, then y is going positive. So this would be a positive infinity. All right, so where does the increasing interval means where is it increasing? It's always increasing. I mean, here in this case, it's always decreasing because you read this way. So this is not going to be applicable, and it's decreasing on the whole interval. So we're putting negative infinity to positive infinity. So this is pretty much all you really need to know with the functions. Okay, so the interval means where does it increasing, increasing means, well, when you see these other two graphs, there's parts that are increasing and parts that are decreasing. So that's why we've got these options. If this line were pointing up like this, then all of this would be up here, and then this wouldn't apply. All right, with a line. So a line is either this way or that way. Some other tricky ones would be if you had lines that look like that, which technically that's not a function, so we wouldn't talk about it. And then this one you wouldn't be increasing at all, so both of them wouldn't apply. There would be no increasing because it's the same value no matter what x is. Okay. All right, so let's talk about the next parent function. All right, so this is an absolute value. So we're going to put f of x is equal to the absolute value of x. Okay, now let's talk about what's going on with this function. All right, at this point in the game, you should be able to tell me whether it's stretching, whether it's shrinking, whether it's flipped, whether moving off to the right or left, up or down. You should be able to tell me that. And at this point, I can tell that this is just, if I compare these two, I'm not doing any shrinking or stretching. I don't have a negative in front of it, so there's no flipping. So all I'm doing is moving I'm only moving the parent graph in different directions. So in this case, I'm moving this. This means to the right 1 unit, and this means down 4 units. So what I can do is I can think about what my absolute value of x graph looks like, which is basically a V shape where I'm basically y equals x this way and then this way. Remember, it's a V shape. So all I'm going to do is move those points to this location. So all I have to really do is take a point which normally would be at 0, 0, and I would move it down 4 and to the right 1. Okay, and so there's my new vertex, my new starting point. And then because I'm not doing any stretching or flipping or anything, I can make that little V shape like this and connect the dots. All right, so now we have our graph. Okay, so again, it would have been at 0, 0, because that's where all of these, if you notice, all these parent graphs start at 0, 0, unless we move it, unless we slide it. All right, so we've done that. So the domain, again, where's their graph? Remember these arrow points, make sure this graph extends forever, and then this is going forever that direction as well. So as you're reading, all the x's, they have a graph, all the y's, they have a graph. I mean, excuse me, all the x's in this direction have a graph. So this is all reals again. You can use the crazy R if you want. If you write all reals, I'm cool with it. If you write an R, I'm cool with that too. Now, the range means what is y. Now, y can't be everything. Like y, notice had an arrow pointing all the way down to the y's. Here, there is no arrow that points all the way down to the y's. Notice that all of our action is going in the upwards direction. So y is only increasing, but it starts off the lowest point, which is down here at, what is that, -4. So y can be greater than equal to -4, is what you would put in there for the range. So the y can only be as low as -4 and then increasing. Every single point y's coordinate is going to be bigger than -4 once you get past that spot. How many roots? It hits up to 2 times. Okay, and behavior. Okay, as x is getting bigger, as x is increasing, y is also increasing. Okay, as x is going forever in the negative direction, y is also still increasing. All right, so you have to look, that's why it's important to draw the graph first and then to try to fill out this information. All right, so here's the tricky part. The tricky part on this is you read a graph from left to right. So it says, when is it increasing and where is it decreasing? All right, so as you're reading this graph on the left-hand side, what are the y values doing? If I read that point, then, all right, actually, we'll use this. If I read this point, which is -1, I read this point, the y is -2. If I read this point, y is -3. And if I read this point, y is -4. So the y values are decreasing here, and y is going up that way. So the increasing interval is when y is getting larger, and decreasing when y is getting smaller. Okay, so this is decreasing from -infinity, and it's going all the way up to this point, but we can't include that point because you're not doing anything when you land here. So this is -4 with a parenthesis on it, not a bracket, but a parenthesis, because I don't get to include what's called the vertex, which is our turning point. We don't get to include that one. Okay. Now, if you notice, y is getting larger as we get on this part of the v. So this would be -4 to +infinity. That's when y is getting larger. Okay, so it's increasing. I have this wrong. Scratch that. I'm gonna have to go. These are wrong. I have to pay attention to the x, not the y. Sorry about that. So you'll have some cross-outs. Actually, I'll know if you did my video, if you are that crossed out. Sorry, it's my x values that make y increasing or decreasing. So the x here is 1. That's what I need to put in here instead of the 4s. So it increases from 1 up, okay, and then it decreases x values from -infinity all the way up to 1. Sorry, my increasing and decreasing have to do with the x values, not the y. It's what y is doing, but it's the x that you put in here. Okay? All right, so hopefully when I do this next one, I'll fix my confusion. So I have one more to do. This is the x-squared graph. So this is the quadratic. So right now we've done a linear, an absolute value, and now we're doing quadratic. All right, so what we can do here is we can change this into, first of all, we know what's going to happen here. A is equal to -1, so that means it's going to flip downwards, okay? And I'm going to go put this in my Desmos because that's how we did it when we were learning it. All right, so, and then we just read the point. So that's vertex is 4, 5. Okay, so the vertex equals 4, 5. So we rewrote it. So now the function is equal to, remember let me put that in that just to remind you what the vertex form is, because it makes graphing a heck of a lot easier if you do that. All right, so if you do that, then this is going to be, our function is going to be -1 x minus 4, that's the h, plus 5. Oops, got squared in there. All right, so there, now you know what's happened is the whole shape is shifted to, it's flipped, it's shifted to the right 4, and it's gone up 5. Okay, from its original. So remember, its original is through the origin. So now I just go to 4, 5, 4, 5, 4, 5. Okay. Now you can either read some points off of there, or you can make a table, or you can kind of eyeball it. One of the tricks to doing this is if you're not being affected by any multiplier, any stretching or shrinking, if you go 1 in each direction this way, then the next one you go is 3 in the next direction. And then you can do 5, and then 7, then 9. It actually makes the x-squared graph. If you can't do that, then you go to Desmos, look at some points, and see, like, here's 3, 4. What else can I read? I can read, let's see, let me zoom in a little bit more. So 3, 4 I can read. 2, 1 I can read, 5, 4 I can read, and 6, what is that, 6, 1? 6, 1 I can read. So, which if you notice, that's the points I have. All right, and you make the graph, and again, you're sketching it, and I didn't even hit it very well, but you get the idea. I'm in pen, so I can't erase, but that's your graph for, and again, you're doing this because you want to fill out this information. All right, so you do the graph first, then fill out this information. All right, so your parent function is x squared. Okay, so again, this, just to remind you, let me write down here, you flipped it from the original. You went right 4 and up 5. Okay, so again, knowing translations and knowing how it affects the graph really does make a difference. It actually helped me just figure this out. Normally I would be at 0, 0. Now I'm going over 4 and up 5. That's my new location, and then because I'm flipping, that's why it's facing down. All right, so now we're going to talk domain and range. Again, the domain is all of these functions are all reals, which makes it easy for you. The range, again, this is a maximum this time because it's facing downward, where this was a minimum. This is a maximum. All right, so that means that y can be at most, looks like 5. Okay, it's 5 right here. All right, so that means y has to be less than or equal to 5. All right, that's your range. Number of roots, how many times can it hit the x-axis? Twice. All right, end behavior. All right, so as x is going in this direction, y is going in the negative direction. And as x is going in the negative direction, y is also going in the negative direction. Okay. All right, now again, when we talk about increasing and decreasing, it's what x is doing. So I'm paying attention to this guy's x. So that's what, 4. Okay, so what I want to know is what's going on from 4 going bigger and 4 going smaller. All right, so what's going on with the graph? Okay, so when I talk about when it's decreasing when is the arrow starting high and going low? This is starting high and going low. That's decreasing, like you're going downhill. Okay, going downhill here. So that means from 4 to larger, 4 and bigger, we're what did I do? Decrease. Oops. Jeez. 4 or larger, we're decreasing. Y value is going down. Okay. It's increasing. Y is getting larger as long as x is smaller than 4. Okay, so I'm going to put down here. As long as x is smaller than 4, so that means 3, 2, 1, 0, y is going up. Y keeps increasing. But as soon as x gets, and you can kind of see it this way. If I put my graph kind of like this and say, what is y doing as you're sliding on your x's, sliding up this graph? As long as x is below 4, which is what all these points are going, on the x-axis, as long as x is less than 4, y is going to continue to go up and up and up and up. But as soon as it hits 4, y starts going down, 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 down. So it starts decreasing once x gets beyond 4, which is what this means. So if you're less than 4, y's values are going to continue to go up. While once you get past 4, y's values are going down. And that's how that increasing and decreasing interval works. Okay, and that's it. So you might have to replay this a couple of times, especially with the interval part. Since I messed it a couple of times, but I did explain it correctly when I got to this point. So please look over it. Please do see me if you get a little confused.